So good afternoon everyone. Farin, Prajoti, Lina, Pooja, Kadambari, Shirin, Kishore, Pratiksha, Utkarsha. Prajoti, Lina, Pooja, Kadambari, Shirin, Kishore, Radhika, Shwetanjali, Pooja, स्नेहल, नम्रता, मानसी, श्रद्धा, सुप्राप्ति, मानसी पाटिल, हेमांगी, अन्नान, हर्षदा, निशा, प्रांजलि, प्रणीता, वैशाली, श्वेता, प्रणाली, सीमा, मीरा, आकाश, सागर, ऋतुजा, साहिली, पूजा, प्रवीण, समीक्षा, निकिता, निकिता भेरे, जागृति, लीना ठाकरे, अक्षया, प्रचिति माने, ऋतिक, प्रक्षेप, नीतीश and Kimaya. Welcome you all again and good afternoon. I hope I am audible to all of you. Yes. So let's get started. You all know we have started with the paper chromatography. The last section which we have left out in the previous discussion was regarding visualization or detection. Okay, so sequentially we will summarize it. Okay, yeah, we have dried the chromatogram. Yes, okay, we have dried with the chromatogram. Atharva, good afternoon. Pradnya, good afternoon. Yes. Now what we have done, we have developed the chromatogram, what they have called it as a development process. There are different ways of development with respect to the dimensional characteristics, because paper is a flexible one. You can convert it into any dimension, any format, any shape, and that's why it provides a flexibility, and hence there are different techniques of development, maybe ascending, maybe descending, maybe ascending, descending the hybridization, maybe circular, or maybe two dimensional. So okay, we have already dealt it, and then after development you have to draw the chromatogram. Okay, so up till now we have completed up to this. Okay, yes, Kiran, good afternoon. Okay, so after drawing of the chromatogram, what next? Next is the visualization, or what we can call it in analytical term is called as a detection. Remember, detection is what? The next technique. Okay, so in case of paper chromatography, it is more of a visualizing agents. Okay, use of visualizing agents rather than a detection. Okay, so if a substance is itself a colored one, just like the pigments which earlier scientists have used for the separation purposes, because of the different pigments which have a different color, they can be easily visually detected. Okay, so if you have any compound which is colored one, or any mixture which is a combination of colors, the individual colors after separation can be easily detected. Okay, so no need of any sort of a detection mechanism as such for so called as colored compounds. Okay, colored substances. But if you have a colorless substances, which is a major task for pharmaceutical analysis, because our most of the drugs do not have any color as such. So this is more important for us, because most of the compounds which not show any sort of color, and that's why if you have any colorless substance with you, physical and chemical methods are there to detect the spot. It depends upon what you are going to measure. That means if you are going to measure physical characteristics, remember, if you are going to measure the physical characteristics, then it is a physical method, and if you are going to measure the chemical interaction of the detection agent, visualizing agent with your substance, then it is called as a chemical method. Okay, so If a colored compound, no need to detect as such, we can easily visualize it, okay. And if there is a colorless substance, there are two methods, physical methods and chemical methods. Out of this, physical method is called as a non-specific methods, okay. Non-specific in the sense they are dealing with the physical parameters only, they do not have any specific chemical interaction with respect to the substance, and that's why they are non-specific in nature. The first one is iodine chamber method, very important method for detection of so many compounds in pharmaceuticals, okay, and especially in academia, okay. In academics, iodine chamber method is widely used because of its simplicity, because of its specificity, and most importantly the quick results it produces, okay. So iodine chamber method, how it looks like, this method, forget about the TLC plate, suppose there is a paper, okay, paper chromatogram with you, you can use the iodine chamber method for TLC also. Remember, TLC also can be easily detected by using iodine chamber method. You just have to keep the iodine chips, okay, iodine chips or the crystals of iodine inside the chamber. Inside the chamber, allow the saturation of the chamber with the iodine fumes, and then introduce this so-called as developed chromatogram. It may be TLC plate or it may be your paper chromatogram. Remember, okay. So what I mean to say is, you just have to introduce your chromatogram, so called as a TLC plate or a paper chromatogram, inside this jar, remember this jar, and in this jar you already kept the iodine crystals, okay. Iodine crystals are already there, and these iodine crystals after fumigation will produce fumes of iodines, and these, when they get stick with your sample, it results into a yellowish color, okay. It results into the yellowish color, which can be easily detected and marked by the examiner, okay. Yes, Raj Bhangre and Sajid Patan, welcome. Okay, so this is the first method, which is also called as the physical method or iodine chamber method, in which you have to take iodine crystals inside a jar, a packed jar, and in which you have to keep your TLC plate or a paper chromatogram, which is already developed and more importantly a dried one, inside the jar, which is already saturated with iodine fumes, okay, with iodine fumes. This is the first method. The second method, which we generally use in case of our analysis purposes, is UV chamber method. In our college also we use this UV chamber method for the compound which shows the absorption in the UV range, okay, and also in the visible range, okay. So if a compound shows the absorption in case of UV range, these compounds can be easily detected under the UV light, or more specifically UV chamber. We have that UV chamber cabinet with us. Just you have to keep this plate or a paper chromatogram inside that chamber. Suppose this is the chamber, okay, and inside that chamber you just have to keep your paper or TLC plate, and here is the UV light whose switch has been kept over here. Suppose this is the switch, you just have to on the switch, okay. As soon as you on the switch, UV lights allow the detection of so-called as previously non-visible spots very easily, and this is also the second method called as a UV chamber method or UV cabinet method. So these two are the so-called as the non-specific methods or a physical method. Now the specific methods. Now these specific methods involves the interaction of chemicals with your substances, okay. These specific methods are also called as a spraying method, because you need to spray the chemical on your chromatogram. You need to spray a chemical on your chromatogram. Now the specific methods is because are also called as a chemical method or also called as a spraying method. There are different combinations of chemicals which can be effectively used for analysis or more specifically identification of certain groups of chemicals. Just like there are certain examples, ferric chloride solution, if you prepare it and allow it to spray by using any sprayer, okay, you can use this sprayer over here, or you can use your simple sprayer also. This sprayer, when gets sprayed on the paper chromatogram, if that paper chromatogram contains the phenolic compound and tannins, remember, if that paper chromatogram contains phenolic compounds and tannins, these gets highlighted by its interaction with the ferric chloride, and you will get so called as yellowish spots on the paper chromatogram. Okay, yellowish spots on the paper chromatogram by employing ferric chloride solution and spraying it onto the paper chromatogram, and this technique will also be used in case of TLC plates. Okay, so the first chemical is ferric chloride for detection of phenolic compounds and tannin. You just have to remember these so called as matches, these pairs. Okay, so second and most importantly and widely used in case of pharmacy or academia is ninhydrin in acetone solution. This ninhydrin has exceptional capacity to detect the amino acids. Okay, and we will have the practical of paper chromatography by detection of amino acids, and for that purpose you need to have a ninhydrin solution. Okay, if you spray the ninhydrin in acetone solution on the paper chromatogram which you have run for amino acid separation, you come to know that there has been a visualization in the blue form for different amino acids. Okay, for different amino acids, these ninhydrin in acetone has been used. Okay, Dragon drops reagents. Dragon drops you already know in case of organic chemistry, Dragon drops reagents. This is useful for detection of alkaloids, 3,5-dinitrobenzoic acid for cardiac glycosides. So these are some of the examples of so-called the specific methods, chemical method, or the spraying methods. So I hope you have cleared with what is specific and what is non-specific. Non-specific is not specific with respect to its chemical interaction, because it utilizes the iodine's characteristics to impart its color to the so-called as the spots, UV chamber's capacity to so-called as illuminate the light of the spot. So these two techniques can be effectively classified under the name of non-specific methods, and specific methods are there so called by the name itself, the chemical methods or the spraying methods. In this method you just have to spray certain chemical compositions or chemical solutions onto the chromatogram. It may be a paper chromatogram or it may be a thin layer chromatogram. Those combinations will be like this. For detection of phenolic compounds and tannins, you can employ the ferric chloride solutions. For determination of amino acids, you can go for the ninhydrin and acetone solution. For alkaloids, Dragon drop reagents, and for cardiac glycosides, 3,5-dinitrobenzoic acid can be effectively employed. Now the classification can also be depending upon whether this technique is destructive or non-destructive in nature. As you all know, in case of analysis, destructive means you cannot recollect the sample. Okay, so called as in case of your chromatography, the term recovery has been used. The term recovery has been used for the purposes when you can easily recover the sample. Okay, if you can easily recover the sample after elution, suppose paper chromatogram or even HPLC, the chromatogram column elutes out the sample. After detection, it can be easily collected separately. Then this technique is called as a non-destructive, because it does not destruct the sample and you can easily carry out the further analysis of the sample because its chemical and physical properties are intact. Okay, now if there are techniques so called as destructive techniques, they carry out the so called as chemical destabilization. It may be physical destabilization and resulting into the complete destruction or chemical changes inside the so called as the original compounds, which further cannot be analyzed by using any spectroscopic methods. If you want to go for any spectroscopic determination of so called as analyzed compound or isolated compounds, this cannot cannot be possible for destructive techniques. Okay, for that purpose you need to have non-destructive techniques. Okay, I hope you clear with the destructive and non-destructive techniques. Now, specific spray reagents, samples destroyed before the detection. Most of the so-called as your chemical techniques or specific techniques or spraying techniques are specifically classified under the name of destructive technique. Remember this, destructive techniques more specifically can be synonymously called as a destructive technique because these two, destructive and specific techniques, carry out the destruction of the sample which you are going to analyze. Okay, carry out the destruction in this case more specifically a chemical one. Remember, the destruction which they carry out more specifically is a chemical one, and if any compound has been changed from its original form to another chemical form, it cannot be called as a original chemical. Okay, and just because of its capacity to convert the molecules into a different molecule so that it can be determined, so that it can be detected, so that it can be visualized, results into destruction of the sample, and hence they are not further analyzed for its analysis purposes in the future for spectroscopic development. For that purpose you need to have a non-destructive techniques. Remember, non-destructive techniques are such a techniques which just utilizes the physical characteristics of the sample, and that's why they are non-destructive in nature, because the chemical characteristics, the chemical sanctity, the chemical structure, the chemical form of the compound will remain the same, and if there is only case which results is the physical dimensions or physical characteristics which evolve to give you the visualization effect, like in case of this Gigamolar Counter. You must have heard this radiopharmaceuticals. These Muller counters can be effectively employed for radioactive materials which emits the alpha, beta or gamma radiations after ionization. This Muller counter has been effectively used for such compounds which are radioactive in nature, first thing, and after the ionization results into so-called as the transmission of alpha, beta and gamma particles. Okay, and the amount of particles which they emit can be synonymously calculated for its quantitative determination. And as we all know, UV chamber and iodine chamber are these two techniques, so called as the non-specific techniques, are effectively used or effectively classified under the non-destructive techniques. Okay, so the destructive and non-destructive techniques can be easily detected. Okay, Dipesh Patil, good afternoon. Now, for quantitative estimation, you can classify the detection analysis into two techniques, direct techniques and indirect techniques. Now, what exactly the difference between these direct and indirect techniques? We will have, first one is direct. Okay, as the name itself suggests, you are not going to have any chemical modifications, or more specifically what I mean to say, you can easily visualize the spots and go for a quantitative estimation. Remember, these two techniques are there for quantitative estimation. Okay, so we are not concerned with the qualitative estimation from here onwards. From here onwards we are focusing more on quantitative estimation. Remember, now quantitative estimation is there, that quantitative estimation can be classified into two types, direct techniques and indirect techniques. Direct techniques further classified into 2 to 3 types. By using different techniques you can go for direct measurement. First one is comparison of the visible spots. Okay, if you go for any iodine chamber methods, if you go for UV cabinet methods, or even your spot is directly visible just because it contains the colored compounds, just you need to compare it. A rough quantitative measurements can be possible. Okay, a rough, remember, it's not so called as analytically breved, or what we can call a brevity. The concise form or the accurate form of quantitative estimation cannot be possible by using comparison of visible spots. You can go for a rough quantitative measurements. Now, how you can carry out the quantitative estimation? By comparison. Component in a mixture can be carried out by comparing the intensity. Remember, the two terms important over here is the intensity and size of the spot. Remember, intensity and size of the spot with the standard substance. Okay, what you have done, you have developed the chromatogram, paper chromatogram, by running the sample. Okay, by running, forget me for this diagram, we will. Okay, so if you have any chromatogram with you, okay, so this is the chromatogram. Yeah, and this is the baseline, as we all know. This is so called as a reference substance, or a reference or a standard substance, and this is the sample A, which is under analysis. So the reference or a standard can be labeled as a S, and a sample can be labeled as a S1. Okay, now after analysis, after carry out the development and analysis, you come to know that this sample reference will give you the so called as spot over here, and sample 1 will also give you the spot over here. You come to know that sample may contains the standard sample, and you can easily carry out the intensity determination, how intense the spot of sample with respect to the standard substance. Okay, how intense the spot of the sample with respect to the standard, and how large the sample, how large the spot sample sample spot with respect to the standard spot. These two techniques can be so called as the rough analytical techniques. We cannot say that we can completely know how the quantitative estimation can be possible if two compounds we will have to go for two different methods. Okay, we will have to go for two different, because if you carry out the analysis by using neat hydrogen spot, then you cannot determine the alkaloids, and if you determine the alkaloids by using so called as, what is the technique, drag and drop techniques, you use it, you cannot carry out the analysis of amino acids. So you have to go for two techniques. Okay, two techniques. In that case, if you are not comfortable, go for this so called as non-specific techniques. Okay, the UV light will show you how many spots are there with respect to the reference and sample 1, sample 2, sample 3. And this has a major advantage, like it cannot result into destruction of the sample also. So you can go for non-destructive methods rather than this so called as a chemical method. But if you know your compound is only alkaloids, then go for drag and drop reagents. And if you know your compound contains only amino acids, go for neat hydrogen solution. And if you are unable to carry out unable to have any primary data with you, go for non-specific methods like the iodine chamber, UV chamber. And if you are not satisfied with these so called as non-specific methods, then go for the periodic or subsequent chemical interaction. Okay, yes. So this is the comparison, you can directly, but this is the rough quantitative. Remember, a rough quantitative measurement. Photodensitometry. Okay, as we are going to have intensity or density measurement of the spot, remember, you are going to have comparison of standard spot with respect to the sample spot. So you can use the density parameters of the spot also. How dense the parameters of sample 1 is with respect to the standard one. So this can be employed in case of photodensitometry. The method is used with the chromatograms of the colored compounds which are dense enough. The instruments which measures the quantitatively the density of the spots. Density of the colored compound can be compared with the standard colored compound, and you can come to know that how dense the compound is and how dense the mixture is, and on that basis you can quantitatively determine what should be the quantitative parameters of the present mixture of the sample. So you can use the photodensitometry also. Next one is this Gigamolar counter. This Gigamolar counter is there in case of radiopharmaceuticals. You must have read this. This instrument is used for measuring the ionizing radiations. Okay, if your compound contains any radioactive material and which has a capacity to emit, alpha, beta, or a gamma rays or a gamma particles after ionization. After ionization, if your compound is radioactive enough and emits alpha, beta and gamma radiations, by ionization effect you can easily determine the amount of radiations alpha, beta or gamma from that particular compound, and this can be synonymously or rather coterminously compared with the quantitative estimation and how much of the quantity of that radioactive material is present inside that so-called as a mixture can be easily determined. Okay, but the foremost so-called as a criteria, the foremost criteria for this Gigamolar method is what? Your compound needs to be ionizing compound needs to be the ionized material or rather radioactive material. Compound needs to show radioactivity in case of ionization radiations. Okay, so this is the Gigamolar methods. Next is the indirect method. These are the direct methods. Direct methods involves comparing your visible spots and photodensitometry, Gigamolar method. Indirect methods in this case can be easily classified. In this technique, the spots are cut into the portions and eluted with the solvents. Okay, one way to do the indirect method is you have to just cut down the spot. Okay, cut that spot. Suppose this is the chromatogram. This is called a recovery, a recovery in case of chromatography. Suppose this is your spot, just cut that spot, okay, portion of the spot, and carry out its recovery by dissolving it into the suitable solvent. Okay, just dissolve that particular cut or sample into a suitable solvent. This is again get analyzed by using spectrometry. You go for any spectrometric method, means just like your UV is there, IR is there, mass spectroscopy methods can be effectively employed, but they are very costly enough. So you can also go for electrochemical conductivity parameter determination by using electrochemical method also. So this is the indirect methods. Okay, so you can go for spectrometric estimation. As we all know, after dilution, after the dilution you can easily carry out the analysis by using UV also. The same can be possible with respect to the IR, NMR and mass. You can go for electrochemical properties determination for particular sample by dissolving. First you need to cut down that particular portion of the sample from the paper chromatogram, dissolve it into the appropriate solvent, and then carry out the spectrophotometric estimation. This is called the indirect method. Okay, so the direct and indirect methods are clear, but the most important and so-called as a practically a very important part of the paper chromatography is the RF value or a retardation factor. Remember, this is synonymously or rather so many times have been asked in your exams. Okay, the RF factor, and even it is important to understand this RF factor for practical purposes also. There are practicals with respect to your paper chromatography, there are practicals with respect to the TLC also, where you need to calculate the RF value, a retardation factor, the capacity of the sample to get a retard or more specifically capacity of the stationary phase. In case in the paper chromatography, it is a paper capacity of the paper or a stationary phase to retard the different components of the sample is what the retardation factor is, and how you are going to calculate it is what the basis of this RF value is. Okay, in paper chromatography the results are represented by the RF value, which represents the movement or migration of the solute relative to the solvent front. Remember, if anyone asks you what is RF value, it is the ratio of, okay, it is the ratio of movement of the or migration of the solute with respect to its movement to the solvent. Remember this term for further references. Remember, RF represents what? The movement or the migration of the solute relative or with respect to the solvent front. As we all know, solvent front is what? The amount of travel or the distance traveled by the solvent. As soon as we come to the development purpose, after the development, you mark the solvent run distance by using any pencil or any marking system. This is called the solvent front. Okay, we already dealt it. this is solvent front. Now this is what the sampling baseline or zero line. Okay, now what I mean to say, the RF value can be calculated by the ratio of distance traveled by the solute. Remember, solute in a numerator and the distance traveled by the solvent front to the distance traveled by the solvent front. What I mean to say, if you want to calculate the RF value for any sample, suppose this is A, this compound is A, this compound is B, this compound is C, and this compound is a D. Okay, now the distance traveled by A is what? This much, from this to this. Okay, distance traveled by solvent is this. You can calculate easily. Now carry out the ratio of distance traveled by A, solute A, to the distance traveled by the solvent front, that is SF. Okay, so you will get the RF value for A. Same way for the second compound B, you can go for B to the distance traveled by SF. Same for C, same for D. So you can go for number of sample analysis for determination of RF value. So have you got the concept of RF value? RF value is nothing but the movement or migration of the solute with respect to the solvent, okay, or a solvent front. And in the mathematical terms, it can be called as distance traveled by the solute to the distance traveled by the solvent front. Then there is another value called as Rx value. Okay, Rx value. If suppose by somehow you are unable to concentrate on that you need to cut down the development by 70% distance. As soon as the solvent runs the 70%, you just have to remove the paper. You may have forgotten due to some techniques, deliberately, non-deliberately, you have certain works, or there may be possibility that you have engaged with another work. In that case, the solvent will travel throughout the paper now. Okay, solvent in this case will travel throughout the paper, and there is no solvent front as such. Remember, if a solvent travels throughout the paper, throughout the TLC plates, in that case there is no solvent front, and hence there should not be any RF value, because there is no specific solvent front distance you can calculate it. So for that purpose, in many cases it has been observed that the solvent front is run off the end of the paper. If the complete paper has been traveled by the solvent, in that case solvent front will not be generated, and hence you cannot calculate the distance also. In that case, the Rx value is used. Now what is Rx value? Rx value is the ratio of distance traveled by the sample to the distance traveled by the standard. Remember, we have to use the standard also. If you use two substances, this is the standard, this is A, sample A, and this is sample B. So in that case, where the solvent front cannot be easily detected, in that case the distance traveled by the standard sample to the distance traveled by, or rather, sorry, it is the distance traveled by the sample to the distance traveled by standard. Okay, so the sample to the standard, okay, distance traveled by standard is what? Rx is what? Rx. It is not Rf, it is Rx. Okay, so this is the difference between Rf and Rx. So have you got the difference between Rf and Rx? Let me know in the comment box. Have you got the difference? Rf is there for those paper chromatogram where solvent front can be easily detected, or solvent front has been easily generated and you can easily determine the distance, but in certain way you are unable to calculate the solvent front, or you can enable to judge the distance of a solvent front. In that case you have to calculate the Rx, not Rf, by comparing it with the distance traveled with the sample. Okay, yes, okay. So the last part of the paper chromatography is applications. Though paper chromatography generously has been more of an academic origin or academic application, but still has been widely used for so many so-called, as specifically amino acids separation, peptides, alkaloids, sugars, lipids, and biological samples. If you have any biological sample, it may be sera, it may be plasma, it may be blood, the amount of amino acids, peptides, alkaloids, sugars, and lipids present in any biological samples can be determined by using or separated out by using paper chromatography to the limited extent as a preparative method, because it is very difficult to recover the sample. For preparative methods or preparative chromatography, you have to recover the sample, and recovery of a sample in case of paper chromatography is a tedious job. Hence it has a limited application with respect to the preparative chromatography. More importantly, as I already said, amino acid study is a very fascinating area or fascinating application for the paper chromatography. Hence, to study the structure and composition of the amino acids and more specifically proteins can be possible by using paper chromatography. And apart from this, analysis of the blood, hemoglobin, urine, which is of a great diagnostic value, which we have already covering it in case of our so many detection techniques, where you need to carry out the separation of blood, hemoglobin, and urine components for diagnostic purposes, can be easily possible by using paper chromatography. Okay, so these are the applications. Okay, so if you have any doubt regarding the so-called, if I mean to summarize the paper chromatography, it's a simple method. You must have heard this, it's a simple method, but it is a time consuming as compared to the HPLC, because you cannot force the sample by using pumping system as in case of HPLC. It is inexpensive. Remember, it is inexpensive because you just need to have a saturation chamber with you and a paper, a Wattman filter paper that summarizes the instrumentation part as compared to your so-called as HPLC and HPTLC, so many advanced technique which are very costly in nature. Shows excellent resolving power also. Resolving power, especially the biological samples, can be resolved very specifically by using paper chromatography, but this technique is non-specific in nature. It has a limited application in case of preparative chromatography, and more specifically from the practical aspects which I can summarize is that paper chromatography is more of a skilled person's perspective. That what I mean to say, the success of a paper chromatography will be synonymously or directly proportional to the skills of the analyst. Means how you are going to spot the sample, okay, how you are going to saturate the chamber, how you are going to spray the sample, how you are going to mark the spots which you have detected. These all are so-called the skilled sets or skilled applications of your analyst, and that's why this technique has its own limitations with respect to its skill set requirement, which can be developed, but still it is one sort of disadvantage with respect to the paper chromatography. This is sufficient in case of paper chromatography. If you have any doubt with respect to this technique, you can raise it over here. We already okay, and this is last lecture, no need. Okay, if you have any doubt, you can raise it over here. In the next lecture, from the next lecture, we will have a discussion on another fascinating technique called as the thin layer chromatography. If you have any doubt, you can raise it. Shall I conclude it? Okay, this is important from the academics point of view, because you have to carry out the practical of the same in our lab also. Okay, if you have any doubt, shall I conclude it? I think there is no doubt as such. Okay, we will meet tomorrow again. We will meet tomorrow again for TLC. Okay, another fascinating technique. Yes, okay. I will send it gas chromatography and paper chromatography in a group. Okay. Anything else? Okay. I hope this summarizes our session. Do not forget to like our session. We will meet tomorrow again. Thank you for watching. Take care.